In identifying maxima or minima, what do we do if the second derivative is 0? Check what to do here in differential calculus. How do we look for the critical points? Having a given function, take the derivative in order to have the slope. And from the highest or lowest points, the slope is 0. Equating the first derivative to 0, we can look for x. So to complete the critical point, substitute x into the original function to have y. Learning about the critical point, next is to categorize if it is the maximum or the minimum point. That is by looking for the second derivative of y, and then check if y double prime is negative or positive. If it is negative, the critical point is a maxima, or the highest point. And if y double prime is positive, then the critical point is the lowest, or the minima. The fourth example involves the function a cubed y is equal to x raised to 4. The first step is to locate the critical points, and that is by taking the first derivative. The function has a cubed with y, but then a cubed being a constant can be cross-multiplied to the other side to create an explicit function. So y is now x raised to 4 upon a cubed. Differentiate this function to find the slope. dy over dx is y prime. 1 upon a cubed is a constant extracted out. Then the derivative of x raised to 4 is 4x cubed with the derivative of x with respect to x from chain rule. Dx over dx is 1. So y prime is simplified as 4x cubed over a cubed. Now equate this slope to 0, then cross-multiply a cubed to get 4x cubed as equal to 0. So x is then 0. With x already found, we look for the y-coordinate by plugging x into the original function. A cubed y then becomes 0 raised to 4. So y is also solved as 0. Therefore, the critical point is at 0, 0. The next step is to identify if the critical point is a maxima or a minima. We identify it by taking the second derivative. With y prime as 4x cubed upon a cubed, we take its derivative to come up with y double prime. Y double prime is then the constant 4 upon a cubed with the derivative of x cubed as 3x squared. Then attach the derivative of x as required in chain rule. Dx over dx is 1. So y double prime is simplified as 12x squared over a cubed. Plugging in x as 0, y double prime becomes 12 times the square of 0 over a cubed, which is 0. Because y double prime is 0, this shows that the second derivative test failed. So we continue validating maxima minima using the first derivative test. In this test, locate the critical point x of 0. And this is the dividing line for the test. From the range where x is less than 0, we assume x of negative 1. Place this into the first derivative equation and have 4 times negative 1 cubed over a cubed. Y prime turns to be negative 4 over a cubed. The negative slope means that from top left, the curve slides down to the right. From the other side, where x is more than 0, assume x of positive 1. The slope is then 4 of 1 cubed upon a cubed. Y prime is 4 over a cubed, which is positive. A positive slope starts from lower left, rising to the right. The two slopes then show that the critical point is a minima.